Good evening, or morning, or afternoon, or whatever time it is when you're watching this. Welcome to part 6 of the Surds topic. Okay, today we're looking at something called rationalising the denominator. And this is going to be broken into 2 parts. Okay, so we're going to look at the first part today. It's the first type of denominators, which are called monomial denominators. Monomial. Okay. Now remember we looked at binomial products last lesson. Well, binomial denominators will be the second of this rationalising the denominator part. So monomial simply means that we've got one term. Okay, so let's write some notes. If a fraction has a surd in the denominator, we usually like to make the denominator rational. Say in its denominator, okay, so we've got a fraction, it's got a surd in the denominator, but we usually rewrite this fraction. We usually rewrite the fraction so that the denominator no longer has a surd and is instead rational. So that's what we mean by rationalising the denominator. Okay, so that's the idea really. We will just define what monomial means a bit better. So just off to the side, let's have a little look at defining what monomial means. Okay, monomial means we have one term. Okay, so for example, the square root of 3, right? It's just one term. Or 2 root 5, it's one term. Unlike binomial, which was 2 terms, 3 plus the square root of 2. Okay, so that's binomial, and we'll look at those sort of questions in the next lesson. But for now, let's look at rationalising the denominator with some monomial denominators. Alright, we've got 4 examples today. In each of these examples, we want to rewrite with a rational denominator. Rewrite with a rational denominator. Remember, denominator is the bottom of a fraction. Alright, here we go. Number 1. 3 divided by root 3. 3 over root 3. Okay, we have a denominator that is a surd. We want to rewrite this fraction with a rational denominator. How do we turn a surd into a rational number? If we think back to one of the key rules we learnt, it is that, let's see if this will write for me. Alright. No. Let's go back to screen. There we go. Alright, sorry. We learned that the square root of x squared is just x. Or, in other words, if we take the square root of x and times it by itself, we get x. So what can we times root 3 by to get a rational number? We can times it by root 3. But whatever we do to the bottom of a fraction, we must do to the top of a fraction. Otherwise, we will completely change the fraction. So we still want to keep this fraction the same. Okay, it's just going to look different. Alrighty, so we're timesing the top and the bottom by the square root of 3. Now the reason we did that is because on the denominator, we get root 3 times root 3, which is just 3. And on the top, we have 3 times root 3. Now, is there any cancelling we can do? There sure is. We can cancel this 3 with this 3, and our answer is simply the square root of 3. Alright, let's have a look at another example. 1 on 5 root 2. Let's rewrite this with a rational denominator. Now, on first inspection, it might seem like, well, the first example we times it by itself, so let's do the same here and let's times by 5 root 2 on 5 root 2. But the 5 is already rational. We just want to get rid of the surd part, which is the square root of 2. So let's just times by the square root of 2. And whatever we do to the bottom, we do to the top. So, what do we get? Why did we times by the square root of 2? Well, root 2 times root 2 is just 2. So on the bottom, we have 5 times 2. And on the top, we have one lot of root 2, which is root 2. And simplifying that denominator, we get root 2 on 10. Example 3. Root 5 divided by root 12. So here we do have a surd on the denominator, but we've also got a surd in the numerator as well. But it doesn't make much difference apart from the fact that we can simplify first. Can we simplify the square root of 5? No. But we can simplify the square root of 12. What square number goes into 12? Well, that would be 4. And the square root of 4 is 2. And what's left over is the square root of 3. Now, this becomes like example 2, in that we only have to multiply by the square root of 3 on the bottom in order to rationalise the denominator. Whatever we do to the bottom, we do to the top. The reason we multiply by the square root of 3 is so that on the bottom we get root 3 times root 3, which is just 3. So we have 2 times 3 on the bottom, and root 5 times root 3 on the top. Now remember, our product rule for surds, we can put those under the 1 square root. 5 3s are 15. And tidying that up, we get the square root of 15 is it? Oh, sorry. The square root of 15 over 6. Alright, last example. Let's stay on the one page. I'll just go across over here. Example 4. 2 plus root 3. So that's an example of a binomial, but this is the numerator. We're only interested in rationalising the denominator. 2 plus root 3 over 2 root 3. Alright, we are going to multiply by the square root of 3. Multiplied by the square root of 3, multiplied by the square root of 3. Get rid of that. Alright, we have to make sure that we multiply on the top we multiply the square root of 3 by both terms. Okay, so let's first write it with some brackets. So the square root of 3 multiplied by this whole thing, the whole numerator. And on the bottom, we have 2 times the square root of 3 times the square root of 3 is just 3. Alright, back to the numerator, and we can expand this. Okay, so we're multiplying root 3 by 2, that's 2 root 3, and root 3 by root 3, that's 3. And on the bottom, 2 times 3 is 6. And that's our final answer for example 4. Alright, therein ends the notes. Let's have a quick recap. In this lesson today, we looked at rationalising the denominator. All that means is that if there's a surd in the denominator of a fraction, we usually want to rewrite the fraction with a rational denominator. And we looked at a specific type, that is, fractions with monomial denominators. Now, monomial means we just have one term. So all of our examples just had one term on the denominator. Root 3, 5 root 2, root 12, 2 root 3. Just one term. Next lesson, we'll look at rationalising the denominator with binomial denominators. Alright, thanks for listening.